Ooh, now things are getting funner, grade 11s. We got exponents that are fractions. Oh, my goodness. Maybe just one aside. We don't even need it in this question. But if we've got something, let's say, like b to the power of a half, it's just another way of writing the square root of b. Because we can use our exponent laws that says, well, I'll take another example. Let's take b to the 3/4. That's another way of writing b cubed, and we're taking the 4th root. So this question may have been asked like that, in which case you'd need to change it to the power of a half. Okay, it's not something we actually need in this question directly, but it's just there out of interest when we do need it later. Okay, so we've also got to the power of -1, which opens up another way of simplifying this. I'm going to do it like we've done the one so far. I'm going to look at the numerator, denominator separately, and I'm just going to apply my exponent laws. So we've got this half needs to kind of go to each of these, the coefficient and the variables. So 64 to the power of a half. Now, fortunately, we could just cover this with no understanding at all and pull out your trusty calculator and go 64 to the power of a half, and it just tells you that it's 8. Well, that was magic, so you just write down 8. Now, if you remember what I just said, I said that raising something to the power of a half is the same as square rooting it. So that makes a bit more sense, but we could have just put in the calculator for this idea. Okay, x to the 4 to the half. Okay, x to the 4 to the power of a half. I'm just going to use my exponent laws. Power to a power, just multiply. So 4 times a half, well, I think that's 2. So therefore that's x squared. Okay, well, let's just use the same thinking. Y to the -2, I'm just looking at that last bit there, to the power of a half. Exponent laws, -2 times a half. Calculator's there if you need it. Otherwise you go, well, I know -2, a half of -2 is just -1. So that's y to the -1. So I'm trying to just reinforce the idea that we're just applying our exponent laws and going there. If we can get some other sort of understanding too, that's great. But to start off with, let's just see what these are. So I'm going to keep going here and go, let's look at the denominator now. We've got something to the power of -1. Let's just apply our exponent laws. The first part is 4 to the -1. Now, from your exponent laws, you should possibly know that that's just 1 over 4 to the power of 1. Or, trust your calculator to the rescue again. You punch in 4 to the -1, and you get a quarter. Wasn't too bad. Okay, then we've got x to the -1. Well, that's just x to the -1. And we've got y cubed to the -1. Just multiply the exponents. And we have y to the -3. Okay, well, onwards, upwards. Let's just simplify. 8 divided by a quarter. Well, a quarter goes into 8. Oh, well, maybe we're just checking on the calculator. Or we know, wait, a quarter goes into 1 4 times and 1 goes into 8 times. So we should get 32. Let's just check it here. 8 divided by a quarter is 32. Okay, so we've got 32. X squared divided by x to the -1. Bases are the same, so we just need to subtract exponents. 2 minus -1 is x to the 3. Let's do the same for our y's. Bases are the same, we're dividing, so let's just subtract exponents. -1 minus -3, well, that's just going to give us -1 minus -3 is -1 plus 3 if you wanted to think of it that way. So that's just y squared. There we go. There's our final answer. Now, there'll be other cases where it will be useful to prime factorize, where 64 you could write as 2 to the something, 4 you could write as 2 to the something. We'll get to those questions just now. For now, we don't need it, so I'll see you in the next one.